The most diverse substances are transported and distributed in piping systems every single day. They can include solvents and chemicals, oil and gas, coolants in primary industry, or steam for energy transmission. The fluids flowing through pipes often have completely different properties. Consequently, different principles for their measurement are required. One method is flow measurement based on the vortex principle. In 16th century Italy, Leonardo da Vinci observed how vortices form in flowing water. Some 400 years later, Hungarian physicist Theodor von Karman described the physical laws that govern how these vortices take shape. Here's how this measurement method works. Inside each vortex flow meter, a bluff body is located in the middle of the pipe. This body is a kind of obstruction that disturbs the flow. Downstream from the bluff body is a mechanical sensor which can register the tiniest pressure differences in the flowing fluid. If the fluid is not flowing, no vortices form. As soon as the fluid starts to move and reaches a certain flow rate, vortices gradually appear downstream of the bluff body. These vortices are detached alternately on either side of the bluff body and are carried away by the flowing fluid. Zones of high or low pressure now appear downstream and thus create a phenomenon that is known as the Karman vortex street. These differences in pressure exactly match the frequency of the passing vortices and are precisely registered by the mechanical sensor, shown here in slow motion. This sensor is unique because it's inherently so well balanced that pipe-borne vibrations of up to 1 G, pressure surges, and temperature shocks have no effect whatsoever on the measurement. The distance between two consecutive vortices corresponds to a defined volume of fluid. Therefore, total flow can be calculated by counting the vortices that pass. The higher the flow velocity, the higher the measured frequency of vortices. In some applications, the velocity is too low for perceptible vortices to form. However, the velocity can be increased simply by installing a vortex meter that has a reduced cross-section. This modification does not affect the measuring accuracy. Functionality can be enhanced by incorporating optional temperature measurement into the sensor. A configuration like this, together with a built-in flow computer, can calculate temperature-dependent mass or energy flow. This feature is particularly important in industrial processes involving saturated steam or gases. In today's marketplace, vortex flow meters from Endress+Hauser are the world's most robust and reliable with a lifelong calibration factor. They have won several prestigious awards and widespread acclaim. For all applications, we have the right solution. Endress+Hauser, your single-source supplier for measurement technology.